Hello again. So I've got another question on mechanics for you. So this is about pulley. Simple case pulley where you just got an object either side connected by a light inextensible string. Okay, so here we go. Two particles A, B, masses 5m and km, where k is less than 5. Basically it's saying that that's the heavier one. That's why it's saying k is less than 5. The particles are connected by a light inextensible string which passes over a smooth light pulley. System held at rest with the string taut and the hanging parts of the string vertical with A and B at the same height above the horizontal plane as shown in the diagram. So basically, system is held at rest and A and B are the same height above the horizontal plane. System released from rest. After release, A descends because A is the heaviest one. Okay, A descends with acceleration at quarter g. So what will happen is A will go downwards and B will go upwards at the same rate. Okay. Show that the tension of the string as A descends is this, 15/4 mg. Find the value of K and state how you've used the information that the pulley is smooth. Okay. We can answer that one now, I suppose. Pulley is smooth, tensions will be exactly the same. Okay. Tensions are exactly the same, which then helps us to set up the equations and solve them. So that's part C answered. Afterwards, after descending for 1.2 seconds, A reaches the plane. So basically A is going to fall and hit the floor. It is immediately brought to rest by the impact of the plane, so it stops dead when it hits the floor. The initial distance between B and the pulley is such that in the subsequent motion B does not reach the pulley. So when A hits the floor, B is not going to reach the pulley, okay? Find the greatest height reached by B above the plane. Right. So let's just have a look at this bit to begin with, shall we? So what I'm going to do is I'm just going to summarise it here. So we've got our diagram. Let's just put in some forces. So here we're going to have B, and that's going to be K, M, G is the weight, and the tension is going to be here, T. And for A, same again. That was part C, wasn't it? Explain how we use the fact that the pulley is smooth. So the tensions are exactly the same, and the weight for A is going to be 5 mg. And what happens is it accelerates downwards, doesn't it? So there's a downwards acceleration, and let's just quickly have a look at what that was again. So 1/4 g. So 1/4 g, and I'm going to do an acceleration arrow on this side because B is going to be going upwards. So that's the same rate, 1/4 g. And what we'll do is just set up some equations and solve them. So I'm going to begin with A. So particle A, and because A is moving downwards, 5 mg will be positive. So 5 mg, and then opposing that, subtract the tension, and that's equal to the mass times acceleration. So 5 m multiplied by 1/4 g. When it says find the tension and masses are given in terms of m, just look out for your final answer being in terms of m. We don't have enough information to be able to work out what m is at the moment, okay? So we're just going to rearrange that one. See, sometimes you're not told what the acceleration is, and then you have to do it simultaneously with simultaneous equations. But because we're told the acceleration, t is effectively our main unknown that we're looking for. So let's just simplify this a bit. 5 mg minus t is equal to, and that would be 5/4 mg. We'll bring this over to that side and this over to that side, and rewrite it like this. T is equal to then 5 subtract 5/4. What's that? 20/4 subtract 5/4. That's going to be 15/4 mg. Okay, that's that bit done. Next, find the value of K. To do that, we're going to have to look at what's happening with B. So with B, it's moving upwards. So T is going to be positive, and opposing that will be the weight. So subtract K, M, G is equal to mass, which is Km multiplied by acceleration. Again, it's 1/4 g. Now we know what the tension is, don't we? So we can just substitute that in. So 15/4 mg, and then subtract K, mg is equal to, let's simplify that, so that's 1/4 K, mg. Okay. Now, this is the nice bit. when you've got an equation like this, notice all the m's will cancel out. Okay, and the nice thing about sometimes using g instead of 9.8 is that the g's will cancel out. The thing is, if you use 9.8 here, you don't necessarily see it because it will be 1504 times 9.8, another number, 9.8, and then a quarter of number. You won't necessarily see it, but when it's all in terms of g, you can just cancel all the g's like that, you see. And that's sometimes why in our information things are in terms of g, okay, or g there. Okay, so let's have a look and cancel the m's as well, and let's just write that a bit more neatly, shall we? So we've got 15 over 4 subtract k is equal to 1/4 k. Always like to write the next line more neatly. Put this k onto that side, so that's going to be 5 over 4k, and then that will stay there, so that'll be 15 over 4. So I'm going to times both sides by 4 to get 5k equals 15, and then k is equal to 3. Let's just check. This was a show, that question, wasn't it? So I'm just going to put in a therefore at that point, okay? Because when it's a show, that question, normally it's a good idea to highlight to the examiner that you've done it. So this working effectively shows, therefore, that t is equal to 15 over 4 mg as required, and find the value of k, done that 3. This one, just to reiterate, same values of t for a smooth pulley. Okay. Just give me a moment, I'm going to set it up for the next part of the question. Okay, I'm ready now for the last bit, set it up. So after descending for 1.2 seconds, A reaches the plane. It's then immediately brought to rest by the impact with the plane. So basically A is going to fall and it's going to hit the plane. What will happen is that B will go up for a little bit, but what it's saying is that it will not ever reach the pulley. Okay, so B is going to rise, but it will never actually reach the pulley. So there's a long enough gap, long enough distance, so that B does not actually reach the pulley as A hits the plane. Okay, we've got to find the greatest height reached by B above the plane. So let's just think about that for a moment. Okay, so A is going to hit the plane, B is going to move the same distance, of course, but then B is not just going to suddenly stop dead, is it? No. So B is going to actually go up a little bit more. A will stop dead as it hits the plane, but B, the natural cause of the thing is, when A hits the plane, B will go up a little bit more, won't it? Before gradually come back down again, okay? Because once it goes up, it comes down again, okay? We've got to do calculations to work out how far it is before A hits the plane, and then how much further B goes up, okay? Let's do that first. Let's see how far it is before A hits the plane, because I'm not told that. So, working on particle A, okay, what do we know? We know that the acceleration downwards is 1/4 g. We're told that the time it takes to descend is 1.2 seconds. And we're also told, I'll show you, that the system is released from rest. Okay, so system is released from rest, that means u is 0. Look out for that, because that happens quite a lot in these scenarios, these types of questions. A system released from rest always means u is going to be 0. Okay, so here we go. U is equal to 0. And we want to find how far A falls, so we've got to work at S, haven't we? Okay, we've got to find what S is. So I'm going to use S equals ut plus half AT squared. Okay, so S equals ut plus half AT squared. And the nice thing, of course, is that u is 0, so the first term is 0. Half times A, so that's going to be 1/4 times a half, which is 1/8. G times T squared. I'm just going to put it in times 1.2 squared, and I'm going to work it out. Okay, so calculator time. So 1.2 squared, and then divided by 8. So that's 9/50ths. I tell you what, I'm going to work it out as an actual value, because when it says find the greatest height, realistically it wants it as an actual numerical value, not something times g. So I'm just going to put g into that now. So times that by 9.8. And we get 1.764. Okay, so 1.764 meters. Okay, so that's how far A has fallen to hit the ground. Okay, let's just think about that at the moment. Okay, so what that means is that the distance from here to the ground, here say, is 1.764 1.64 meters. I'm exaggerating a little bit because, of course, B does not hit the pulley. When A travels down that much, B will travel up that much. So now B is going to be double that above the ground. Okay. So B is going to be double that. Just remember that. Okay. I did say that when A hits the ground, it stops dead. B doesn't stop dead because it's in mid-air. There's nothing for it to stop. It doesn't reach the pulley. You keep going for a little bit. It now becomes a particle falling freely under gravity because the tension of the string will no longer be there. The string will be slack. That's the whole thing about the string being taut. You see, when the string is taut, the objects move together at the same rate. But when one of the objects has stopped and the other one keeps on going, the string suddenly becomes slack. Okay. So just bear that in mind when we do our next calculations. We're going to have to work out how fast B is moving before it starts falling freely under gravity. Okay. So when A hits the ground, it'll hit the ground at the same speed as when B starts that initial phase of moving freely under gravity. So what I want to do is I want to work out what the final speed here is. Okay, for A, the speed at which A hits the ground. For that, I'm going to use V equals U plus AT. Okay, so same bits of information. U is 0, your A is a quarter G, and you've got T is 1.2. And I'm going to again use my calculator for that. So 1.2 divided by 4, of course, 3/10 times by 9.8, and that is 2.94. 2.94 meters per second. Okay, so what that means is after right here, after A hits the ground, B is moving with speed U is 2.94. You happy with that? So after A hits the ground, B is now moving at 2.94 meters per second, and that's the initial speed we're going to take for the next bit of motion. Okay. For the next bit of motion, we're looking to see when it reaches its maximum height, when the greatest height is reached. And as you know, particle falling freely under gravity, the maximum height will be V equals 0. So it goes up with initial speed U, and then maximum height, V is 0, comes back down again, but we're more interested in what that maximum height is. And we know acceleration. Okay? The acceleration is falling purely due to gravity. Okay, so that's going to be negative 9.8. Remember, it's negative because B is moving upwards, the acceleration is downwards. Okay, and we want to work out S's. I'm going to use V squared equals U squared plus 2AS. Okay, what a great question this is. I'm getting to use all the formulae here. So U plus AT, that one. I like questions like that where you get to use a variety of formulae. Okay. So you've got 0 is equal to U squared, 2.94 squared. Calculator time again. On the downside, I don't like questions where I have to use a calculator as much. Okay. I prefer questions where calculator is not used at all. So the ideal question is you get to use a lot of different equations, a lot of different cool stuff, but no calculator. That's the ideal question for me. 8.6436. So still, this is a good question, but not perfect. 2 times A, so negative 19.6 S. We arrange that a little bit, so 19.6 S is equal to 8.6436. S will be that number divided by 19.6. So divided by 19.6 equals 0.441 meters. So basically it means falling 300 grams of B moves just a little bit more. It's quite a bit, isn't it? 44 centimeters, just that little bit more. Okay. So what is the greatest height? So therefore height. Okay. Right. Just recap. Remember, A falls that much, which means B must have started that much above the ground. So B started that much above the ground, 1.764. And then as A falls that much, B must travel that much because they're moving together. Okay, so that's going to be that distance is doubled. And then the extra bit it moves falling freely under gravity to its maximum height will be 0.441. Let's work out what this is. So plus 1.764 764 times by 2. So 3.969 meters. Not quite at the end yet, because if we're using G in our calculations and we're given a number as a numerical value, we should really round it to two significant figures, because G is 9.8 that we're using for G, two significant figures. So I'm going to round that. That's going to be 4.0 meters, isn't it? It's two significant figures. Yeah. There we are. Yeah, that's all done. Yeah. Hope you enjoyed that question. I hope you got something out of it. I'll see you again.